Hello, in this video I'm going to show you how to use OpenCV, CUDA, and Gstreamer on Jetson Nano NVIDIA devices to run your computer vision application, and how to stream your video from the webcam to other devices without accessing to the edge devices. So the first step is to install the requirement library. In this case, you need to install OpenCV and the CUDA, and because we use NVIDIA Jetson already in the OS from the NVIDIA, these packages exist and installed on your system. Otherwise, I refer you to other video in my channel to learn more about installing the OpenCV, Gstreamer, CUDA, and updating Python and other packages that required for your computer vision project. So the first step to install OpenCV, CUDA, Gstreamer, and other requirement packages. Make sure the OpenCV library compiled for using Gstreamer. And in order to transfer your video through the web, you need HTTP server on your NVIDIA. So I'm using Visual Studio Code also, and I connected through the SSH to the NVIDIA devices. This command you need to put on your devices in order to install the HTTP server in order to transmit the video. So we go for Visual Studio Code. Here I set up my Jetson. You need to know the IP address of the machine, the username, and the password. And I just put a host name, and this is important if you want to visually see some GUI from the machine. Later on we use also that part. And this config file is easily when you want to connect from Visual Studio Code to the HSS machine. You install the extension here for SSH, and here you can click for open remote window, and here we select the remote SSH. And for the first time, if you want, you can config the file, and I config the file for my user. I use Mac OS, so on your OS, it's Mac OS, Linux, or Windows, you can have a different path. And this config bar, you just need to add these lines. And after you add these lines, you just simply by clicking here and select the name of the host, you connect to the machine. Here you enter the password, hit enter. For the first time, you need to install the code. Now everything is set up, and you can open the folder inside the machine. I create a folder here. Okay. Now I access to the edge devices, and from here you can write your code and run your code. So because I use CUDA, I need to create a file with the .cu as a CUDA and put everything here. So let me copy the path for this file. Setup, as I mentioned, in VSCode, install SSH extension, and then config the IP for NVIDIA devices. The path is this, and what we inside is host is can be any name, and okay. After I connecting to the devices, now we want to write a code. First, we use CUDA and OpenCV. And after we connected, and this is our file. Okay, I create a file. As I mentioned, it must be CU at the end, and put it here, just so you know. Okay. For the simplicity of the running and compiling your code, we can use makefile. Okay, and inside the makefile, we can write a command, for example, compile, C. And here we can write a command for compiling our code. The compiler for CUDA is NVCC, and we use C++ 14 and -o, the name of the file, and the name of the source code. Okay. Now we write a very simple code just to check everything right. Okay, for example, just the name. I open up terminal and run it here. Just make compile C. Else, okay, we can see the file exists, and we can write it and see the result. The result is here. Okay, now everything set up correctly. Now we want to go and connect to the webcam and show it on the devices through the HTTP server that run on the edge devices. Yes, we need some packages, and later on I explain why I use these packages. These are OpenCV library packages. When you install OpenCV, you have all these headers, and these two headers also using for the CUDA. You can only use this functionality on NVIDIA GPU devices that you have. Because we have a Jetson Nano, we have this functionality and this CUDA version library on the device, so we can run. This is some packages for the C++, and this is a HTTP server. Later on we use it, and some other headers. Now we can define or say port number, and also using other namespace for the CV and using namespace for the CV CUDA. Okay. Now we need some variable to hold each frame of the webcam, and also some buffer for the using other functionality for the program. So first, let's the vector unsigned char and frame buffer the automatic as boolean and on. Okay. For the webcam, OpenCV has a functionality to read any kind of webcam easily, video capture, and okay, we have a function for sending information to the page. Structure HT connection page. Then the response is the response of the MHT create respond. Buffer and this page, and then for the star page MHT where MHT respond page. Okay. Response function HTTP. Okay. Okay, and destroy response time. Okay. Now we have another function to capture the frames from the webcam. Void capture frames. Okay. Also, we want to use CUDA to convert the color to the grayscale images inside the GPU and then pass the image to the buffer. So we get the frame from the webcam, modify it, and send it to the buffer, and the buffer send it to the HTTP. Okay, here we need GPU math. GPU frame and math also frame and a vector for the buffer. Vector for Ansanja for JPEG buffer. Okay, while is running, from the capture to the frame. From the camera. The camera already video capture. It takes from the webcam first frame and put it to the buffer of the mat. This is OpenCV. And then we upload to the GPU. In between, we can also check if empty or not. But I want to write a very simple program just to test and run. Later on, I will complete it with a lot of different testing and debugging inside the code and put it to my GitHub repository. Okay, now we pass this frame to the buffer, to the GPU frame that we created. And dot upload frame. Okay, we get the frame and but we pass it to the GPU. Now inside the GPU, we can use CVT color to modify the color from color to grayscale. GPU frame GPU frame and to modify this color BGR because OpenCV color is a BGR, not RGB. Is a historical way that they put the image information to the BGR to gray. Gray also capital. And then vector int compress parameters. How much compress you want to get the image is depend on your resolution. If you have a very big resolution and the connection between devices is slow, you can convert it, use the quality to lower and have a better compression arms equal IM height underline page underline quality and 95, for example 95. Now we want to use JPEG code for the frame and buffer and compress parameter. JPEG buffer size plus okay. Uh, insert frame and JPEG buffer and JPEG buffer and that for this one, and again frame buffer and just for the ending okay, and this is the end of this function. And we have another function to send information to HTTP server, and for that one I just copy and paste the function that we require for this step. Okay, and then for the final stage we need to open up the webcam and send the information. To open is cap open, and 0 is the first webcam that we access. If we have a 2 or 3 webcam, you need to modify and change this one. And we need to have a thread for capturing capture frames, and for the HTTP we need struct mhd. mhd start. Use select yes, and port number null and null, and handling request null mhd option enter. Cout server running, and just get the Word is running parse, capture, thread, join, and mst stop. And return 0. Okay, because we use a lot of different packaging and libraries, we need to modify the makefile. For modifying the makefile, we need to have some library add to this one. So we need to add OpenCV. This is one way to do it. This is to find the OpenCV and add it, and also and okay, we can now compile. Same command as before. Okay, couldn't find the OpenCV. This is wrong. Config again. It must automatically find the OpenCV. PKG config select libs OpenCV. Check the comment here also. Yeah. Okay, we have some error. Line 28. Ah, const. Another one, line 28. Is the same, I think. And line 74. compile again. Okay, compile. Yes, yes, I try to run it. Okay, server is run. Now we can open new tab in browser and go to the URL. Um, okay, just you need to pass the IP of your devices. And this IP and the port number, and then video feed. Yeah, as you can see, I connected successfully to the devices, and you can see the result. Thank you.